United States conducted a new atmospheric test on March 1, 1954. That day, they detonated an H-bomb under the code name Bravo. The fireball they measured was 50 kilometers high and 11 kilometers wide. The 15 megaton blast of Bravo was 3 times more powerful than expected and 1,000 times more powerful than Hiroshima. The wind also changed directions without warning. Radioactive ash fell on inhabited islands, exposing the local population to high levels of radiation. An emergency evacuation was organized for 250 people. But it was another event that became front-page news. Radioactive ash fell on the Lucky Dragon, a Japanese tuna fishing boat sailing 190 kilometers from ground zero in an authorized area. When the boat returned home 2 weeks later, the crew was suffering from burns and nausea. They had radiation sickness. One of the crew members died 6 months later. Geiger counters rattled fiercely throughout the boat. The tuna fish and sharks that were caught were also highly contaminated and could not be sold. They were buried at night under the fish market, away from prying eyes. The dramatic events surrounding the Lucky Dragon triggered a wave of protests in Japan. In addition to the widespread pollution caused around the planet, there was also a risk of nuclear war. The crisis was exacerbated by the fact that, in the 9 years that had passed since Hiroshima and Nagasaki, an increasing number of survivors were being diagnosed with cancer, especially children with leukemia. The general public was becoming more aware of the long-term effects of radiation. Though exposure due to nuclear testing differs from that due to bombs, there was a real cause for concern. In response, the international community created the United Nations Scientific Committee on the Effects of Atomic Radiation. At the same time, the United States launched the Atoms for Peace program to promote the industrial use of nuclear energy.
To help solve the fearful atomic dilemma, to devote its entire heart and mind to find the way by which the miraculous inventiveness of man shall not be dedicated to his death, but consecrated to his life.
But the Cold War was reaching its height, and the arms race continued. Between 1945 and 1980, Russia, the United States, France, China, and the United Kingdom conducted 543 atmospheric nuclear tests. Most of the power was released over a period of 8 years. The record was set in 1962, with 118 tests, representing 1 test every 3 days. Countries then gradually turned to underground testing to avoid producing atmospheric pollution. Each explosion released a large quantity of radioactive particles. Those injected into the low levels of the atmosphere fell in the vicinity, while those injected at higher altitudes were dispersed over thousands of kilometers by the wind. Radioactive residue from the most powerful blasts remained in the stratosphere for several months before falling back to Earth. The nuclear testing sites were located all around the globe, though most of the explosions took place in the northern hemisphere, with nuclear fallout tending to accumulate in the latitudes of these sites. Mainland France was affected because of the US site in Nevada, the Russian site of Semipalatinsk, and the Chinese site of Lap Nor, which were all located on similar latitudes. Let's take a look at the Chinese test on October 16, 1980. The radioactive cloud moved east, drifting with the prevailing winds. It mainly remained between the 30th and 50th parallels north, and crossed over France 6 days later, on October 22nd. Until the 1950s, only professionals were concerned with protecting themselves against rays. In other words, with radiation protection. With the widespread contamination of the Earth by nuclear weapon testing, the whole population was now concerned. The public was exposed, and needed to be protected. But man does not live in a laboratory with airlocks and lead screens. Radioactive elements reach man via an extremely complex and diverse system called the environment. The environment was a field that had been practically ignored by nuclear physicists, who had received support from meteorologists, agronomists, and veterinarians, and which would eventually result in a new discipline, radioecology. Its objective? Understanding the mechanisms involved in transferring radioactivity to man. This new field of science, born out of nuclear weapon testing, would develop rapidly beginning in the 1970s, hand in hand with the civil nuclear power programs launched around the world and the need to control power plant discharges. It would also play a vital role in the aftermath of the Chernobyl accident in 1986, helping to protect populations located in areas contaminated by the catastrophe. With the recent increase in awareness concerning the need to protect the environment, radioecology has now become less focused on human beings alone. The Earth's flora and fauna must also be protected. It has placed the role of humans in a different perspective.